or polarity. Now, when looking at a molecule to determine whether it's polar or not, we can look at the symmetry of the molecule and the bonds that are present in the molecule there. So, for example, CO2 here's a Lewis dot structure for carbon dioxide, CO2. It is a pretty symmetrical molecule. If we were to imagine trying to fold this on a piece of paper, and let's be clear, this is a two-dimensional picture, and we're trying to imagine something that's 3 dimensions. But for Gen Chem, this is going well pretty good. This does a lot of good jobs here. If we try to fold this thing on some of its planes, we see that it's pretty symmetrical all the way around. And because it is so symmetrical, we can say that CO2 is non-polar. We can also look at the polarity of the individual bonds. Now, I want to be clear that the word polarity is being used to describe the entire molecule and also the bonds. So I think that's kind of a little point of confusion here, how we use that word so liberally here. If we were to analyze the individual bonds, we would also see symmetry in this molecule. The symmetry of these bonds right here, excuse me, the polarity of these bonds right here would look something like this, where we have the arrow pointing to the more electronegative atom. This is a polar bond here between carbon and oxygen. If we were to look up the electronegativity values and take the difference, it'd be greater than 0.4. Notice the symmetry in the polarity of the bonds. Like there's still symmetry in this molecule here. So let's consider another example here. SO2. So this molecule here, SO2, in this static two-dimensional image here, we have, it really takes on a symmetry, excuse me, it really takes on the structure of a bent molecule here. This lone pair of electrons on the sulfur is determining the structure of this molecule, the geometry of here. If we look at its symmetry, it is not symmetrical on that dotted line there. I'm going to bet this is a polar molecule because of the lone pair of electrons is not symmetrical on an up and down. It's symmetrical on a left-right, but not an up and down there. Molecules that have a lone pair of electrons on the central atom, they're going to be polar. In this trigonal planar with a lone pair coming off here, having to be asymmetrical and polar molecules. Thank you.